So now as we have seen constant function in case of continuous time signal, let constant 1 you have to represent in continuous time signal, then you have represented it like this, having value 1, it is your constant function x of t, that is 1, having value 1 for every instant of time t. Now if you are going to take a discrete time constant function, then again the function will be having same value, that is constant value. Say you are saying x of n is equals to constant 1, then it will be having value 1 for each values of n. It will be 1 for each and every value of n. It is your constant function x of n. So it will be existing from minus infinity to plus infinity. A constant always exists from minus infinity to plus infinity. So the values are 1. It is point n equals to 0. So now as you have defined x of t constant 1 to be the sum of u of t plus u of minus t. If you see in case of discrete time function, if you write u of minus n or u of n, then u of n will be having values 1 from 0 to infinity. These values are 1 from 0 to infinity, origin at this point, and all other values before origin are going to be 0. These values are 0. Again you will be taking time reversal to find u of minus n, and the signal will be existing only till t n equals to 0, that is it will be having value 1 only before origin and it will be having value 0 after origin. So if you are going to add up these two values, then u of n plus u of minus n is going to give you values 1 everywhere, but except at n equals to 0. If you are adding, then 0 plus 1 is 1, 0 plus 1 is 1, all values after n equals to 0, again 0 plus 1, that is 1, 1 and 1, so on. But now at origin, if you see, at origin all these two functions are having value 1, so 1 plus 1 you will be getting 2. And as this 2 value is never repeated in the function, therefore this function cannot be called as a constant function. So if you have to find a constant 1 in discrete time domain, then it must have values 1 from minus infinity to plus infinity. So to find this function, what you can do is, if you take a signal that is having value 1 from 0 to infinity, like this signal, if you say a function that is having value 1 from 0 to infinity, this part can be represented as what? U of n. Now if you have taken signal u of n, that is if you have taken the samples from 0 to infinity, then now what you have to take is, you have to take other samples from minus infinity to minus 1. You have to take a signal which is having value 1 for each instant of n for which n is less than or equals to minus 1. So what is the signal which exists from minus infinity to minus 1 with a value 1? You know that if you plot a signal that is u of minus n minus 1, if you plot u of minus n minus 1, then this signal will be existing from minus infinity to minus 1. We have seen that due to this negative sign, this signal will be starting from minus infinity and it will be terminating at minus 1. So if it is a signal that is u of minus n minus 1 which is having values 1 from minus infinity to minus 1, and if we add up in this signal this u of n function which is having value 1 from 0 to infinity, then sum of these two functions will result in the constant one that will be having value 1 from minus infinity to plus infinity. So now you can write in discrete time case that if we take u of n plus u of minus n minus 1, then it will give you the constant 1. So it is again very important, because as we have defined 1 in continuous time domain to be ut plus u of minus t, then we have taken the property that if we have to define any particular signal only for t greater than 0, then we can multiply ut with it and we can write. Similarly, if we have to define any signal only for t less than 0, then we can multiply u of minus t with it. But now you can see that u of n plus u of minus n minus 1 is 1. It means that now if you have to define say any signal x of n, that is a to the power mod of n, these things will be using repeatedly in our future lectures. Therefore we are just trying to define at least these terms, then how we are going to take the values of a to the power mod of n. Now we have discussed that this mod of n is what? Mod of n is going to be plus n for n greater than 0, and it is going to be minus n for n less than 0. You can take equality sign on any of the two. So it is mod of n is plus n for n greater than 0 and it is minus n for n less than 0. So if you see here, this function can be written as it is a to the power n for n greater than 0 or equals to 0, and it can be taken as a to the power, if we are taking for negative values of n, then this mod of n will be replaced by minus n. So it will give you a to the power minus n for n less than 0. So if a signal is defined only for positive values, then now we can write this signal x of n to be, with this definition we can write x of n to be, this function can be written as a to the power n u of n. It will define that the value of the signal x of n is going to be x of a to the power n, but only if n is greater than or equals to 0, because we have associated this function u of n with it. Again, for this part you can use a sign positive a to the power minus n, and for this signal which is n is less than 0 and n must be an integer. So what is the integer that is less than 0? The first integer, that will be minus 1. So this will be the value for n equals to minus infinity to minus 1. Therefore you can write with this term u of minus n minus 1. So now we can take a to the power mod of n, like if we have taken e to the power minus a mod of t. If you have taken this signal in case of continuous time, then we have written that e to the power at minus at u of t plus e to the power at u of minus t. What you have done here, you just have taken the values of this mod of t equals to plus t for t greater than 0. For t greater than 0 we have used ut and we have taken plus t, therefore it is e to the power minus t. For t less than 0 we have used u of minus t, and for t less than 0 mod of t is minus of t, therefore this function is e to the power at. So you can see another difference between continuous and discrete, that if we are going to describe a signal which is existing from minus infinity to plus infinity, then we must have to define it one part with u of n, which is having values of samples from n equals to 0 to infinity, and the other part must contain samples only in between minus infinity to minus 1. It must not be existing at n equals to 0. So we have defined it in two parts, first part from 0 to infinity and second part from minus infinity to minus 1. For this part, mod of n is positive, therefore this factor is a to the power plus n, and for this part as n is negative, so mod of n is negative, therefore this factor has become a to the power minus n. So these differences must be taken care. Now we are going to discuss, like if we say it is your function u of t, you have seen that it is your function u of t, and with respect to t having value 1 for t greater than 0, and it is your function with respect to t, that is u of minus t having value 1 only before t equals to 0. It is t equals to 0 point. So now if you are going to subtract this signal from this signal, that means if you are going to find out the value of u of t minus of u of minus t, then what we will be obtaining? You are subtracting this signal from this signal. This signal is having value 0 from minus infinity to 0 and it is having value 1. So 0 minus 1 will give you minus 1 from minus infinity to 0. So the result will be minus 1 from minus infinity to 0. At t equals to 0, if you see, the values of both the function can be approximated to 0.5. So 0.5 minus 0.5 will give you 0. So at t equals to 0, the value is 0. Again after t equals to 0, if you see, this value is plus 1 and it is 0, therefore 1 minus 0 you are going to get value plus 1. So it is a function which is having value minus 1 for t less than 0, it is the point of t equals to 0. So this function is having value minus 1 for t less than 0. For t greater than 0, the function is plus 1, but at t equals to 0, the value of function is 0. So this function particularly is known to be a special function that is defined to be a signum function and represented to be signum of t. So if you are taking any such signal which is having value plus and minus 1 in either sides, then it is going to be your function signum of t. So this signum of t can be mathematically defined as it is having value plus 1 for t greater than 0, having value minus 1 for t less than 0. and if you want to approximate or exactly if you can define exact value of this function at t equals to 0, and the value is going to be 0, where at t equals to 0. So it is our next function, next elementary signal you can consider, that is signum of t, which is 1 for t greater than 0, minus 1 for t less than 0, and 0 at t equals to 0. How we have find out the value at t equals to 0? Again you can use the Gibbs phenomena. If it is having discontinuity at t equals to 0, then signum of 0, that is equals to signum of 0 minus plus signum of 0 plus divided by 2. That is, using Gibbs phenomena, if there is a discontinuity at any point, value is suddenly changing from minus 1 to 1, then if you want to approximate that value at t equals to 0, then you will be taking value just before 0 and value just after 0, and you will be taking the average of these two. Value just before 0 is minus 1, value just after 0 is plus 1, so the result at t equals to 0, value will be 0. So you have taken this definition. Again, you can define signum of t in one more way. If you see, it is your constant 1, or see if you plot 2 ut, if you have to plot 2 ut, then if it would be ut, then the value will be 1. If you are plotting 2 ut, then this value will be 2. The amplitude of this signal after t equals to 0 is 2. If you are going to subtract a constant 1, if you subtract a constant 1, let it is any function x of t that is equals to constant 1 having value 1 for every value of t. If you are going to subtract this function from this signal, then 0 minus 1 will give you minus 1 for t less than 0, and after t equals to 0 it is 2, it is 1, so 2 minus 1 will giving you 1. So signum of t can be either, signum of t can be written either 2 u of t minus 1, or it can be written u of t minus of u of minus t. Again, how you can find this relation? You can replace this one to be u of t plus u of minus t. Then again you can find out this relation. So these two are basic definitions of signum function relating with step function, and mathematically we can express signum function like this. So if we have to perform operations on signum function, then we are going to define operation on signum function. As we have taken the relation, that is, we are defining signum in terms of step function. So if we want to define step function in terms of signum function, then you can write, we have written signum of t is equals to 2 u of t minus 1. So what else can be taken from here, that if you are going to replace this t value from any other t value, that is, if you have to plot signum of t plus or minus t naught, then it can be defined just by taking t plus minus t naught minus 1. It is constant, it will not be having any effect by the replacement of t values. So if you are going to replace t by t plus or minus t naught in LHS, then only this part will get replaced and this value will satisfy this. But it is not as that important as what we are going to discuss now. If you find the value of u of t in terms of signum of t, then you can find step function u of t can be defined as signum of t plus 1 and divided by 2. So u of t can be taken as signum of t plus 1 by 2. So if it is a step signal, then it can be defined like this. If it is a shifted step signal, that is, again if we replace this t by t plus or minus t naught, then it will be signum of t plus or minus t naught plus 1 divided by 2. It is very important, as we have seen that we can represent any given signal which is having sudden changes can be represented in terms of step function. And if we are able to represent any function in terms of step function, then we must represent that function in terms of signum function, as we have written here that any step function can be represented in terms of signum function. So now we are going to replace, use these relations, and we are going to perform some operations on signum function. Now if we talk about operations on signum function, then we have defined first signum function mathematically as signum of t is going to be having value 1, 0 and minus 1. It is for t greater than 0, for t equals to 0 and for t less than 0. Again the function is discontinuous at t equals to 0, and we have seen that, and we can analyze. We have not discussed the properties, that is even and odd functions, but still you very much know this. Let it is function signum of t given like this. Then if you see here, the values are plus and minus 1. So, this function is, let it is your function x of t, then you know that for any function x of t, if you are going to take the time reversal and you will be getting your signal back, that is if x of minus t is going to be same as that of x of t, then the signal x of t is said to be even, and if you are taking time reversal x of minus t and if it is going to be minus of x of t, that is if the effect of time reversal is similar to that of amplitude reversal, then the signal is said to be odd function. So, if you see here, if it is your function signum of t, that is x of t, if you plot x of minus t for the signal, that is if you are going to plot x of minus t, that is signum of minus t, x of t is signum of t, so we have written x of minus t, that is signum of minus t, then it will be having value plus 1 for t less than 0 and minus 1 for value of t greater than 0. So, now you can see that if you compare these two signals, then you can say that if it is your x of t, if you multiply this signal by minus 1, that is if you are going to take the amplitude reversal on this signal, then 1 will turn to be minus 1 and this value minus 1 will be now plus 1. So, this function signum of t is satisfying this condition that x of minus t is minus of x of t. Therefore, you can say that signum of t is an odd function. It means if it is an odd function, first thing that if for any function to be odd, it must be having value 0 at origin. If the value at origin is other than 0, then a function can never be a odd function. So, it is satisfying that relation also, it is having the value 0 at t equals to 0, so it is an odd function. If it is an odd function, it means x of minus t is going to be minus of x of t. So, x of t we are taking as signum of t, so signum of minus t is going to be minus of signum of t. Signum of minus t can be written to be as minus of signum of t. Now, again if you replace t by t plus or minus t naught, then you can write signum of minus of t plus or minus t naught will be same as that of minus of signum of t plus or minus t naught. So, these can be remembered. Now, if we directly apply operations, then say if you have to find out, first if we have to find out any signal x of t, that is signum of t plus 1, simply we just have to take time shifting in signum function. We know that it is our signum function signum of t, and if we are talking about signum of t plus 1, that we have replaced this t by t plus 1, it means we are going to shift this signal towards left hand side by 1 unit. Then this point of discontinuity which was earlier occurring at t equals to 0, now this point of discontinuity will be occurring at t equals to minus 1 as we have shifted the signal by 1 unit towards left hand side. So, this signum of t plus 1 can directly be taken by the use of time shifting, and it will be having values plus and minus 1. Now, this point will be t is equals to minus 1, it is your signum of t plus 1, which can be obtained using the definition that if signum of t is defined, then you replace t by t plus 1. So, it will be 1, 0 and minus 1 for now t plus 1 greater than 0, t plus 1 equals to 0 and t plus 1 less than 0. So, from here you will be taking, you will be finding value t equals to minus 1. So, signal will be 1 for t greater than minus 1, that we have plotted here. Signal is plus 1 for t greater than minus 1, it is minus 1 for t less than minus 1, and it is having value 0 at t equals to minus 1 from this relation. So, both the definitions can be used either, or you can directly perform operations moving from right to left. Now, if we have to perform combined operations on this signum function, like if we have to plot, say we have to plot the signal, that is x of t is equals to signum of say 4 minus t plus 2. If we have to plot this signal, signum of 4 minus t plus 2. So, these can be considered to be two different signals. First signal is a signum part and the second part is a constant function. So, you know that whenever you are going to add some constant to any other function, then the value of that function is just going to be shifted upward or downward depending on the polarity of this constant. So, this constant can be added later on, but first we have to calculate the value of or the plot of signal of 4 minus t. This part, if we name it as let it is our signal x1 of t and it is our signal x2 of t. So we know that x2 of t is a constant. We have to find out this. So x1 of t is written to be signum of 4 minus t, which can either be written as signum of minus t plus 4. You can write down like this. So if you want to perform operations moving from right to left, if you want to follow that method, no problem with that. So you must have to apply a time shift of 4 seconds. So now you can first plot this function with respect to t, that is signum of t plus 4, and if you are going to take advancement by 4, then you will be shifting your signal towards left hand side by 4 units. So this point of discontinuity will be lying now at t is equals to minus 4. This is your signum function and you just have shifted this function towards left hand side by 4 units. Therefore this point, which was earlier occurring at t equals to 0, now it has shifted to t is equals to minus 4. So we have plotted signum of t plus 4. Now we have to take time reversal on it. Therefore after taking time reversal, what you are getting is this function at what earlier the discontinuity was lying at minus 4. When you take time reversal, you shift all negative values to positive side. So this continuity will be now lying at t is equals to plus 4. As this plot has reversed, so the polarities will be like this. It will be like this. We just have taken time reversal. This is value plus 1 and minus 1. It is your signal, signum of 4 minus t either or minus t plus 4. So it is your signal which is having discontinuity at t is equals to 4. Now if you want to use this relation, then directly you can say that signum of 4 minus t will be 1 for 4 minus t greater than 0, 0 for 4 minus t equals to 0 and minus 1 for 4 minus t less than 0. So if you see here, if 4 minus t is greater than 0, if you move minus t to other side, then you will be having sign like this, t must be less than what? 4. You have just shifted this minus t to other side, so the signum function will be having value 1, but only till t is less than 4. So we have plotted value of signal x of t, signum of 4 minus t at 1 before t is equals to 4. Again from this value you can find t must be, now sign will be greater than 4. That is for t greater than 4, the signal will be having value minus 1. So it is the plot which we have obtained by taking shifting and reversal on the signum function. So we have plotted first function. Now we have seen that it is your signal x1 of t that is having discontinuity at t is equals to 4 and having values plus and minus 1. These values are for signal, let it is your x1 of t signal that is defined as signum of 4 minus t. Now if you have to add a constant, what you have to add is a constant. Constant 2 can be represented like this. It is your signal x2 of t, that is nothing but a constant. So if you are going to add up a constant, then you are just going to shift this signal either up or downside. So if the constant is positive, so signal will be having a positive shift. Therefore all these values will get enhanced by amplitude 2. So you can write, now you can plot this signal x of t, that is x1 of t plus x2 of t. So wherever the values was 1, it will get added with 2. So 1 plus 2, the value is be 3, and where the value is minus 1, it is minus 1. So the value will be minus 1 plus 2, that is plus 1. So now the signal will be having the same shape, but these points are now minus 1 plus 2, it will be plus 1, and plus 1 plus 2, it will be plus 3. This point is again t is equals to 4 with respect to t. So now it is your function, that is signum of 4 minus t plus 2. You just have shifted this function, you have taken this function and you have shifted it upward by a magnitude of 2. Therefore this plus 1 magnitude became plus 3 and this minus 1 amplitude became plus 1. So we have plotted this signal like this. So we can perform any operation on signum function, either you can use this definition method or you can use just shifting, reversal or scaling functions. So now if we have to represent any other given function in terms of signum function, so if we have given that, what we have seen to represent, we have written that any step function u of t can be written as signum of t plus 1 divided by 2. And if there would be a shifting in step function, then corresponding shifting will be taken in terms of signum. So if you are having a function which is given to you as, suppose like this. If you are given a signal x of t which is having values from -1, it is t equals to 0, this point is 2, this point is 4 with respect to t, let the values are 10 and 15. So if you have to represent this given signal x of t in terms of a signum function, then signum function, to convert this x of t in terms of signum function, we must have to write this function in terms of step function. If we are able to write this function in terms of step function, then we can convert all of those step functions in terms of signum function. So to write expression in terms of step function, we will be writing expressions only at arrow marks, and at the first arrow is at -1. So the function will be having expression u of t plus 1. Change in amplitude we can see plus 10. Now I can directly write it, and plus 5 u of t minus 5 u of t minus 2 and minus 10 u of t minus 4. So we can write this expression. Now every step function can be changed using this relation only, that u of t plus or minus t naught can be written to be signum of t plus and minus t naught plus 1 divided by 2. So you are just going to replace all these step functions by signum functions. So it will be 10 into signum of t plus 1 plus 1 divided by 2. Again it can be written as 5 into, simply u of t is there, so it will be signum of t plus 1 divided by 2 minus 5 signum of t minus 2 plus 1 divided by 2, and the last one is minus 10 signum of t minus 4 plus 1 divided by 2. So if you see the coefficients, then you can write, if you see the coefficients of constant, then if it is a finite duration signal, then what you are going to get is 10 by 2, that is the constant value will be 5 from here. Again if you see here 1 by 2 into 5, that is 5 by 2. So you are going to have positive values at 10 by 2 from this constant, 5 by 2 from the next value, then you are again going to get minus 5 by 2, and again you are going to get this value as minus 5 or minus 10 by 2. So you can see that all these values will get cancelled and you will be having 0. So the constant term will reduce to 0, and if you see the coefficients of signum, then you can write finally this x of t to be, x of t is equals to 5 signum of t plus 1 plus 5 by 2 signum of t minus 5 by 2 signum of t minus 2 and minus 5 signum of t minus 4. So we have represented the given signal x of t in terms of signum function, and for that we first have converted that given signal x of t in terms of step function, then we have converted all of those step functions into signum function. So we have seen the properties of signum function, that it can be approached by a step function only, and it have two definitions, that it can either be represented by u of t minus of u of minus t, or it can be taken as 2u of t minus 1, and we have taken the relations. So any operation can be performed by using any of the two methods. So we are now going to discuss some questions, or you can see one more thing. If you define signum sequence, as we have first discussed unit step signal, then we have seen its counterpart, that is unit step sequence. Similarly, if you define, you just have to define, very less chance that you are going to get question on discrete time signal, signum. Still you must have to an idea about this function, discrete time signum sequence. Then this discrete time signum sequence is again a sequence that is having values plus and minus 1 for positive and negative values of n. Values of this function is going to be plus 1. It is going to follow the same definition that was in case of continuous time signal, that is, it is having value either plus 1 or minus 1. These values are plus 1, these values are minus 1. But what you can see here also, it is your function signum of n. You can see here this function is going to be existing from minus infinity to plus infinity. The signal is 0 at n equals to 0. Again we have plotted a signal which is having value plus 1 for every positive values of n, and it is having value minus 1 for every negative values of n, but it is 0 at n equals to 0. So this function can again be mathematically represented as signum of n is going to be plus 1 for n greater than 0, 0 for n equals to 0 and minus 1 for n less than 0. Now it is from the very basic definition of signum function in case of step only, and in case of continuous time we just have taken samples of that signal. To convert any discrete time signal, what is the procedure? Only we have to take samples of that signal. So we have taken the samples on positive and negative half, and we are getting the values to be plus and minus 1. So it can be represented again in terms of discrete time unit sequence, as we have represented in case of continuous time signal. Similarly, we can represent this signum of n. See, we can take two definitions again. Signum of n, if you take u of n minus of u of minus n, what will be the values? U of n will be having value from 0 to infinity, all values are 1. U of minus n will be the values 1, but from minus infinity to 0. So if you are going to subtract, then before n equals to 0 this function is 0, so 0 minus 1 the values will be minus 1, as in case of signal. For n greater than 0 this function is 0, so 1 minus 0 you will be having value plus 1. But at n equals to 0 both of these functions are 1, so 1 minus 1 you will be getting value 0. So it can be written as u of n minus of u of minus n. Again it will be having one more representation that I am skipping you, that I am just writing you and I am letting you to verify it by your own. You can write this signal also as u of n minus 1 minus of u of minus n minus 1. See, we can discuss only here that this u of n minus 1 signal, it will be 1 for which instant it is shifted version of step function. So it will be 1 after n equals to 1. So it will be existing from n equals to 1 to infinity. It will be existing, it will be 1, it is equals to 1 for n 1 to infinity. And this signal is going to exist from minus infinity to minus 1. So if you are subtracting these two signals, so this signal is 0 before n equals to 1 and this signal is 1 till n equals to minus 1. So 0 minus 1 you are going to get value minus 1 from minus infinity to minus 1. At n equals to 0 both of these signals are 0, so you are having value 0, and after n equals to 1 this is 1 but it is 0, so 1 minus 0 the value is 1. So you can define signum of n discrete time sequence in two methods, either un minus of u of minus n or by this u of minus n minus 1, u of n minus 1 minus u of minus n minus 1. So you can conclude several things by your own. Take a signal which is anyway represented in terms of signum function. You can take anything in signum, that is if you want to plot x of t, that is equals to minus 2 signum of minus 4t plus 6 by 8 into u of minus t plus 5. So you have to plot, if you have to plot this signal. So what you have to do is you just have to take this function, you just have to plot this function first, which can be plotted either by using two methods. We have seen all of those two methods, and you just have to multiply this signal with u of minus t plus 5. You know that this signal will be existing only from minus infinity to plus 5, and during that interval this signal is going to have value plus 1. Whenever this signal is non-zero, it will be having value 1. It will be having value 1 from minus infinity to 5. It will be having value from 1 from minus infinity to 5. So if you are going to multiply anything by 1, then you will be having the same value. So the value of the signal x of t is going to follow this result, but now the result is confined only during this interval. So you must have to take the plot of this signal, and the resultant signal x of t will be same as that of this signal x of t, but only during the interval where this step function is existing. So you can play with signals, take any signal, take either combination of these signals, either addition or multiplication or subtraction, and as much as you will be practicing, that much perfection you will be gaining. So I am ending this lecture here. Now in the next lecture, hello. in the discussion of elementary signals, we have started our discussion with step function, and we have seen this step function in case of continuous and discrete time. So I am just going to, you can say revise, we are just going to revise the things in just 2 minutes. That you have first drawn your signal unit step function, it is u of t, and its counterpart, that is u of n. Both of these signals, you have said that these are causal signals, and if we multiply these signals with any non-causal signal, then the resultant signal is going to be causal. It is your u of n unit step sequence having values 1. It is for t, and you have defined one more function, that is signum of t, that is using this step function only. You have defined one function, that is signum of t with respect to t having value +1 for t greater than 0 and -1 for t less than 0, and the value at t is equals to 0 is 0. Similarly, you have defined discrete time signum sequence, that is signum of n, and you have taken the same values, that is either +1 or -1, but now the signal is discrete, so it is having values only for integer values of n. Signal is like this, it is having plus and -1 values existing from -infinity to +infinity. These values are -1 and +1. So what properties we have written is, we have defined this signum of t may be represented as signum of t is equals to, either you can write u of t minus of u of minus t, or you can write it 2u of t minus 1. So we have defined that u of t can be obtained as signum of t plus 1 by 2, signum of t plus 1 by 2, and if you want to take any shifting in step function, then accordingly shifting will be added in this signum function also. So what we have seen now, that if we have to check the property, then the first property of signum function is, it is an odd function, and due to the property of odd function, you know that for any odd function, x of minus t is going to be minus of x of t. So you can write signum of minus, if we write t, then it will be equals to, it will be then equals to minus of signum of t, right. If we are going to replace this t by any t plus or minus t naught, then accordingly you have to take same replacement here also, that will be signum of t plus minus t naught. So if there is a time reversal, then you can take this sign of time reversal and make it as amplitude reversal. So signum of minus of t plus minus t naught will be minus of signum of t plus minus t naught. So again, same properties as this discrete counterpart of signum function is again a discrete, again a odd function. So it will again follow this relation, that signum of minus n is going to be minus of signum of n, and the value of signum of n or signum of t at either t equals to 0 or n equals to 0 is defined, that is 0. So now we are going to take one more you can say classification. What we are doing right now, we are just studying all the signals that can come into your exam. These signals are only be there in the question. Whatever will be the question, you will be having question on any particular signal, that can be either unit step function or signum function, or what we are going to take is exponential functions in case of continuous and discrete time domain, then rectangular function, triangular function, ramp function, impulse function, Gaussian function, sampling or sinc function. So we must have to understand these functions, you can say from very basic to very any possible level, so that any question based on the properties of this function must be done by you. So we are now going to take our next function, that is real exponentials, real exponentials. And if we have to take first in case of continuous time, then we are defining continuous time real exponentials. So the common form is going to be, the signal will be given to you as x of t is equals to any constant a e to the power, you can say alpha t. Now one thing that you must notice here, if nothing is mentioned about the existence duration, that is the range of time for which this signal is existing, then you must have to consider it from -infinity to +infinity. But if the word causal is associated, that if it is said that a causal signal x of t having the expression this, it means it is existing only for t greater than 0. One more thing, if you are having options, if nothing is given about the signal, about the existence of the signal, but what you see, if in options you are given all the options for t greater than 0, then in that case you can consider that this signal is existing only for t greater than 0. Otherwise, most probably if the signal is existing for t greater than 0 only, then either it will be defined to you that it is existing for t greater than 0, or it will be said that the signal is causal. So as nothing is mentioned here, so we will have to take this signal existing from minus infinity to plus infinity. So there are three possible cases in which the signal can exist. That if we take case 1, if we say that this value of alpha is 0, if alpha is 0, then x of t is what? Then x of t is going to be a into e to the power 0, that is 1. So x of t is equals to 1, which is a constant. Therefore you will be plotting this signal x of t with respect to t as it is a constant having value 1. It is your signal x of t, that is equals to a times e to the power alpha t for alpha equals to 0. Again, if you are going to change the values of alpha, then the possibilities either alpha can be 0 or alpha can be positive or alpha can be negative. So if we are now going to take, if case 2, if alpha is greater than 0, that is if alpha is positive, then the signal, say we are going to take like if alpha is equals to 1. So if alpha equals to 1, then signal x of t will be e to the power a times e to the power t. Now if you see this function, if you are going to take this t value positive, then exponential, you know that 2.73 approximately it is the having value. So e to the power which is greater than 1, if you are going to take the increasing values of t, then this function will be increasing, and if you increase this t in negative sign, with negative sign, like if we have to plot this signal, if we are going to plot this signal with respect to t, a times e to the power t. If you put t is equals to 0, then it will be e to the power t will be 1, therefore a into 1 will be a. So at t equals to 0, the value of the function is going to be a. If you are going to put t is equals to plus infinity, then 2 to the power 2.73 power plus infinity will give you infinity, and if you will be putting t is equals to minus infinity, then the function will be 0. So you can plot this signal as an exponentially growing signal, which will be written like, which will be plotted like this, and it is your signal, that is e to the power a e to the power alpha t for alpha greater than 0. So it is a growing exponential for alpha greater than 0. Now if we are going to take same exponential, that is a e to the power alpha t, but in the third case, that if we are now going to take the case that if we are going to discuss case 3, that is if alpha is less than 0, that is if alpha is negative, then your signal, let's say alpha is equals to minus 1. So signal x of t is what? In this case, signal x of t is a e to the power minus t. If we have substituted value of alpha to be minus 1, so the signal is a to the power minus t. Now if you are going to put this t value is equals to minus infinity, then minus and minus will give you e to the power plus infinity. That means this signal will have infinite value for t tends to minus infinity. And if you are going to put t tends to plus infinity, then e to the power minus infinity will give you 0. Therefore, it will be a decreasing exponential which will be decreasing its value from infinity to 0 at t tends to 0. It is the values of t, it is your signal x of t, that is e to the power a times e to the power alpha t for alpha less than 0. And if you see again at t equals to 0, this part will be 1, therefore the value of signal is a. So it is e to the power a into e to the power alpha t for alpha less than 0, and it can be said that it is a decaying exponential. It is a decaying exponential. So now we will be studying bounded and unbounded signal. So we have not studied that topic yet, but if we will be defining bounded signal, then a signal is said to be bounded if it has finite values in the overall region where it is existing. If the signal has only finite values, that is if you say that, let's say x of t maximum, if you say the maximum value of x of t is say b, let it is bx, it is the maximum value of b of signal x, and if this value is less than infinity, it means what? The maximum value of signal over the signal, if it is existing in the duration minus t1 to plus t1 or from t1 to t2, then in whichever duration it is existing, if the maximum value possessed by this signal is if less than infinity, then the signal x of t is said to be bounded. Then this signal, then x of t is said to be a bounded signal, a bounded signal. So as you use the word stable in case of system, similarly you use the word bounded for a signal. So if you see here, if this signal is considered, then if you are taking this signal to be anti-causal, it means if this signal is existing only for negative values of t. If these values are eliminated, if we say that this signal is existing only for t less than infinity, t less than 0, it means only this part of signal is considered, then this signal is a bounded signal because the values possessed by this signal, all values are finite. But as we see, if we say that this signal is a causal signal, if it is a causal signal, then you will not be considering this part. If this signal will be causal, that is a signal that is represented by a into e to the power alpha t, and if it is written for t greater than 0, then this signal is a causal signal. Then if you put value of alpha greater than 0, then you will be getting a plot which will be exponentially increasing function. And if you take that function, if you are taking this part of function, then in this part at t tends to infinity, the value of the signal is going to be infinite. That is, this signal is not bounded if it is considered to be a causal signal or a non-causal signal. This signal is bounded only if we consider only this part, that is if we say that this signal is anti-causal, it is existing in negative half of t only, then this signal is a bounded signal. Similarly, you can see if this signal will be causal, then we do not have to consider the negative part, then this signal is a bounded signal because all the values are finite. And if we have to consider anti-causal part of the signal, that if we are saying that only these values are existing in the signal, then you see that in this half the value of signal is increasing, at t tends to minus infinity the value is infinite. Therefore, if this signal is anti-causal, then it is unstable. So, what we have discussed, if x of t that is equals to a e to the power alpha t, where alpha greater than 0, x of t that is e to the power alpha t, if alpha greater than 0, then it is stable if anti-causal. Then this signal is stable or bounded if it is an anti-causal signal, that is if it is existing only in this duration, then this signal can be considered to be stable or bounded signal. And unstable or unbounded if non-causal or causal. Non-causal means if it is existing from minus infinity to infinity, still you can say that it is unbounded because this part is containing. If you say the signal is causal, still this part is containing, therefore you can see in both the cases signal is unstable or unbounded. But if it is considered to be anti-causal, that is if it is existing only in this duration, then it can be said to be a bounded signal. Similarly, this signal will be stable or bounded if it is causal, and if it is non-causal or anti-causal, then this signal is going to be unbounded. So now we are going to take the same exponential, real exponentials, but in case of discrete time. So now if we define discrete time real exponentials, then now the form of the signal is going to be x of n will be equals to a to the power n. Again, there are some possibilities for these values of this constant a. If we are taking case 1, if we take value of a is greater than 1, if you take value of a greater than 1, that is if you say that x of n is equals to 2 to the power n, say a is equals to 2, say we are taking a is equals to 2, that is greater than 1, then this signal will be 2 to the power n. That will be, if you are going to find the values of this signal, again nothing is mentioned about the limits of n. So n can be taken from minus infinity to plus infinity. So now 2 to the power n signal, if you see at n equals to 0, 2 to the power 0 will give you 1. If you will be taking n is equals to 1, then the signal will be having value 2, then 4, 8, 16 and so on. If you are taking n negative, then 2 to the power minus 1, it will be 1 by 2, 1 by 4, 1 by 8 and so on. So this signal is existing from minus infinity to plus infinity, and if you see the values as you increase n, then the value of the samples are increasing. If you are going to decrease the values of n, then the values of samples are decreasing. If you are going to take n equals to minus infinity, then 2 to the power minus infinity will give you 0, and if you will be taking 2 to the power plus infinity, then at n is equals to infinity the values of the signal will be infinite. So if you want to plot this signal, then you can simply plot it. Signal is having values, let us say it is 1, then again it is 2, then 4, 8 and so on. Increasing values with increase in n, it is your signal x of n. and at n equals to minus 1 value is 1 by 2, minus 2 value is 1 by 4. So, it is going to be decreased if you are going to reduce the value of n. It is at n equals to 0. So, again you can see that it is somewhat like following the shape of exponentially growing signal. So, it is said to be discrete time real exponential, and in particular for alpha or a greater than 1, it is a growing exponential, but growing unipolar, you can say unipolar or unidirectional exponential, as the values are only positive values are contained in the signal. So, if the value of a is greater than plus 1, then you will be having a unipolar exponentially growing signal in form of x of n, that is 2 to the power n. Now, if you are going to take your case 2, if you put in this signal, if you take alpha in between 0 and 1, if alpha or a, the value of a, that is a to the power n signal is represented by, so if we take this value of a in between 0 and 1, say if we are taking value of a is equals to 1 by 2, then the signal you will be obtaining is x of n, that will be 1 by 2 to the power n. Now, if you see the values of this signal, then at n equals to 0 again the value is going to be 1, but at n equals to 1, 1 by 2, n equals to 2, the value will be 1 by 4, then value will be 1 by 8 and so on. So, now if you see here, then the values will be 2, 4, 8 and so on. So, what you can see now, at n equals to 0 value is 1, and if we increase n in the right hand side, then the values are going to be decreased, and if we increase n in the negative side, then the values are going to be increased. It means you can plot this signal as a decaying exponential with respect to n. The sample values in the signals are going to be 1, 2, 4, 8 and so on. These values are 8, 4, 2, 1, then 1 by 2, then 1 by 4, 1 by 8 and so on. So, again it is a decaying exponential. So, if the value of a is going to be in between 0 and 1, then you will again be having a unipolar signal. It is again decaying but unipolar signal, which has only one polarity is in values that are positive values. So, if we have taken the second case, if we take the third case, if we take case 3, that is now if we say case 3, if we are now going to take the values of this alpha in the range if alpha is greater than minus 1 but less than 0, that is earlierly we have taken the values of alpha to be positive and increasing existing in the duration from 0 to 1. Now, we are taking values of alpha to be from minus 1 to 0. Say we are taking the value of alpha to be minus 1 by 2. Now, you can see the effect that x of n, that is again going to be a to the power n, where a are actually we are taking a. So, it is a. So, if you are taking value of a to be minus 1 by 2, then the signal will be minus 1 by 2 to the power n. Now, if you see here, if you are going to put any even number for n, then this negative sign will be positive, but now if you are taking any odd values of n, then odd power of this minus 1 is going to be negative. So, the value of signal x of n at n equals to 0 is again equals to 1, but at n equals to 1 the value is going to be minus 1 by 2, at n equals to 2 the value is going to be plus 1 by 4, then minus 1 by 8, plus 1 by 16 and so on. And in this side, if you are going to take n equals to minus 1, so power minus 1 will give you, it will be minus 2, then it will be plus 4, minus 8 and so on. If you put value of minus 1 by 2, if you are going to take the value to be minus 3, it means you are going to take minus 2 to the power 3. Power minus 3, it means you are going to take 1 upon this value and you will be taking 3 power of that. So, we can take minus 2 to the power 3, it will be giving you minus 8. So, we have written minus 8 here. So, now you see the values are now bipolar, that is alternate signs are coming in the sample values, that after a positive sample you are going to get a negative sample and then again a positive sample you will be having. And the values, if you say magnitude is decreasing with respect to n, that is if you plot this signal, with respect to n, now you are going to plot x of n, that is minus 1 by 2 to the power n, then the values, if you say at n equals to 0, value is plus 1, it is plus 1, at n equals to minus 1, the value is minus 2, it is minus 2, then it is plus 4, then it is minus 8, then plus 16 and so on. So these are the values, and again if you see here, then it is going to be minus 1 by 2, then plus 1 by 4, then minus 1 by 8 and so on. So if you see again the values, if you say magnitude, then magnitude of samples are reducing with respect to increase in n. But now this function is bipolar, that is it is having positive as well as negative samples. So it is decaying bipolar exponential in case of discrete time. And the last possibility for the value of a you can take is, if you take case 4, that is if you say that alpha or a is now less than minus 1. If a is less than minus 1, first case we have considered a to be greater than 1, then we have taken a in between 0 and plus 1, then we have taken in between minus 1 and 0, and now we are taking that if a is less than minus 1. So say we are taking a is equals to minus 2, then signal x of n is again going to be a to the power n, that is minus 2 to the power n. So if you see the values of the signal, that n equals to 0, the value is again going to be 1. At n equals to 1, the value will be minus 2, n equals to 2, value will be plus 4, then minus 8, then plus 16 and so on. In this side, you will be having values minus 1 by 2. If you put n equals to minus 1, then it will be 1 upon minus 2, that is minus 1 by 2, then plus 1 by 4, then minus 1 by 8 and so on. From minus infinity to plus infinity, this signal is existing. Again you can plot this signal. This signal is having value 1 at n equals to 0, it is your signal x of n. At n equals to plus 1, the value is minus 2, it is minus 2. Then at n equals to 2, the value is plus 4, then the value is minus 8, next value is plus 16 and so on. This signal is going to follow this, and towards left hand side if we see, this value is minus 1 by 2, then it will be plus 1 by 4, it is plus 1 by 4, then minus 1 by 8 and so on. So you can again see that it is a bipolar function, and magnitude of sample is going to be increased as we increase the value of n. So you can say again for this signal, it is a bipolar growing exponential. Actually it is not an exponential, but we see that almost the shape is going to be exponential.